get maths here. Some present value annuities. How's that? Come on, let's vibe it up there. So with our present value annuities, we've got a new formula, right? Looks kind of similar to the one that we just had before, and that is P equals X and all of this stuff. Now the difference is now it's 1 minus and it's a minus N. But let's just jump in straight into an example and go for it. So you buy a car. Does that mean that you're going to be driving around? That's going to be awkward, right? Okay, so maybe you are, and you're like, you got your car, yeah! Okay, so you get your car and you've paid 20% in cash and take out a loan for the balance. Interest is 10.5% per annum compounded monthly. Calculate the monthly repayments if the loan is repaid over 5 years. Doesn't it seem to happen often that things are over 5 years? I don't know. Maybe it's just me and now it's confirmation bias because you're always going to think that. First repayment is due 1 month after the loan has been made. So one kind of crucial bit of information here is that this formula here works when things happen 1 month after the loan has been made, same as the previous one. So we kind of expect that now. So first things first, maybe kind of a mini part A. If you bought the car for 125,000 Rand and you've paid 20%, how much do you still owe on the car? Well, I think that I would just go that times 80%, which I know is 0.8, and into the calculator. So if I look for my calculator, let's just load it up here. Hello, calculator. So there's our calculator, and we go 125,000, and we times by, now I just go 0.8. Do any of you use that percentage button over there? If you do, you said yes, then I'm going to be asking you to help me, please. Because I just do that because I'm so used to changing percentages into decimals, right? We do it all the time anyway. Okay, so there we go. We owe 100,000 Rand. Now we've got our new formula. So let me do this and still scrolling around like a mad person. Goodbye, calculator. No, the sound effect's only when it appears. So calculator is there. So, well, not there. Sorry, our formula is there. So we're just going to substitute our values in. So it's kind of a nice, simple example to get us into it, that our present value is 100,000 Rand. That's what our loan's for. And we need to now pay it back over a certain number of months or compounding periods. And we're going to pay a certain amount every month. We don't know what that is. And so that's X. So we got 1 minus 1 plus our interest rate to the minus N. This is going to be a fraction. That's a fraction. How are you feeling just filling the rest of that formula in and go for it? Okay, well, our interest rate is 10.5, so that over 12, 0.10.5 over 12, and negative N, 5 years, 12 months in a year, negative 60. So, I'm going to say go for it, and I'm going to put a pause in here for you to solve the rest of it, and then I'm going to do it as quickly as I can on the calculator. So let me get my calculator out in the meantime here. Hello, calculator. So, pop a pause and solve, and then I'm going to solve it here. Okay, so you're going to go, and I'm going to do it in the kind of the way that I do it, 0.105 over 12. I like to store that in A, then I like to go 1 plus A, and that's in B. So now I've got A and B, so therefore I can go 100, 1, 2, 3. I would need to times by this denominator. Well, that's just A, so that's now saved me a smidgen of time. So I've got 875. Now, I definitely wouldn't normally show this step, and I'm just showing you so I can see where I am at the moment. 1 plus 0.105 over 12 to the negative 60. That's kind of where I am on the calculator at the moment. So I need to subtract, whoopsie daisy, all of that obviously times X. So I need to divide all of 875 by this monstrosity on the right. So I'm going to go 875, it's already there, divided by, I don't like using the fraction here because then I can just see a bit more. So I want to divide by 1 minus 1 plus, that is B, I already know, and that to the power of negative 60 now, and that should be S, right? So X equals 2149,39. Okay, so that's the monthly repayment over the next gazillion years. Okay, so there we go. That is that. hopefully sort of okay. As I said, most basic example, really, we've plugged in the stuff we know and found out the other bit. Okay, let us look at our next example then. And our next example is, again, sort of simple enough, but now what we're going to work out is something else, not x. So let's read through it together. Jules inherits 500,000 Rand, and she plans to resign from work and live off the inheritance for as long as she can. Right? The dream of some people. Not my dream. I actually love teaching. So, well, you're out of here now anyway. So I was going to say sorry for you, but I'll still be here. She invests the money in a savings account, earning interest at 9.8% per annum compounded monthly. If she withdraws 10,000 Rand each month, find me once, can she live off this? Okay, so got the idea of the story. You inherit all the money, you pop it in the bank, you get interest on it, but you keep withdrawing a little bit each month. How long can you do this for? Just at a complete guess. 500,000 bucks, 10,000 Rand every month. How many months or how many years do you think that this could happen for? No, that's going to be, I think that's an interesting way to kind of go, I wonder what it's going to be. So let's go for it. 500,000 now is the present value, right? That's how much, not future value. It's not like it's going to that. Equals, we withdrawing 10,000 Rand every month. Okay. Our interest rate is 9.8. So we got 0.098 over 12. And up at the top here, we got 1 minus 1 plus 0.098 over 12. And now the thing we don't know is negative n. So maybe just a feeling and then see how you do on solving this. And then I'll solve us through. And yeah, just how you're feeling on solving that. And yeah, interested to see how far you get. Is it to the logs? Ooh, hint, they're going to be logs to use, right? So go for it. Solve and be back. Okay, so there you are. You've solved. You got something, and you said how you did. I'm going to get my calculator up, and here it is. It's too good. And so we got 500. Before we do that, I'm going to store this thing here, as I always do. This is going to be A, and that bit there is going to be B, right? So when it gets to doing stuff here, I'm going to go 500,000 divided by 10,000. I just skipped the thousands. Equals 50. So again, maybe you don't have to show every step, but I'm just going to show it to see where we're at. 50 equals 1. Wait. Equals, what do we do? Do we just divide that by that so far? Okay, this seems like unnecessary to show. Times by the denominator, alpha A. So far what we've got is 7 over 16 equals 1 minus 1 plus 0.098 over 12 to the negative n. Remember this part just b for me, and so that's b. I'm just reminding where we're at. Okay, so we're going to need to subtract 1. Excuse me, subtract 1 from each side. No, not divide. Minus 1 from each side. That's that, and then we're going to have to times that by negative 1, right? Now, am I being silly here? Because plus 1, 7 over 16, I have made a slight mistake. So, do you know what? I'm actually just going to start again quickly. Apologies. All of that seems right in my formula, but I can see that I've kind of messed up somewhere. So let's just figure this out quickly. We've got 0.098 over 12. Shift, store that in A. I wonder if you've spotted where I made my mistake, but I'm hoping that I can cover this all quickly enough. 500, 1, 2, 3, divided by 10, 1, 2, 3, equals 50. Okay, then we need to multiply by our denominator times alpha A. Cool, 49 over 120. That looks good. We need to subtract 1 minus 71 and times by minus 1, and that seems a whole lot better. Maybe it was in the trying to write down in between steps. See, no, not a good idea. Okay, so we're back on track at least. So what we've got is 71 over 120 equals this thing, 1 plus 0.098 over 12 to the negative n. Cool. Now we're going to use our logs, right? Because our logs say that, base stays the same. So negative n equals log that base there. Now I'm just going to write b, because I already spoke up here that this part here is b. Maybe I'm just going to remind anyone reading my work that I've said that that's b. And I'm going to take it of 71 over 120. Now we don't want negative n, we want positive n, so multiply both sides by -1, and into our beloved calculator goes. So I'm just going to put that in C so long. So we've got minus log base was b of 71 over 120, and I get 64 and a half, give or take. So 64, well, let's maybe write that down. 64,552, it's really small on my screen. That many months, which is equal to, give or take, how accurate that looked like, about 5 years. It's always 5 years. And 4.5 months. Now, just to finish us off, how close were you? Did you get it quite close or not? Obviously, I'm going to see the first one, and I'll see that from this. But how close did you get? And yeah, that's that for this first example. Okay, so wonder how close you got. Let's pick up our music again as we head out of here.